Breaking news now involving the gas shortage. Within the last hour,
And if you're trying to save gas during the gas shortage, don't put it in plastic bags.
Panicked drivers lining up at gas stations fearing a fuel shortage.
Honorable jury and colleagues, today Michael Taha and I will be presenting our project, which is solar charging station via Arduino. Before we start, we would like to thank Dr. Gabi Abu Haidar for guiding us throughout this semester, and we would like to introduce our team members.
Today's project, we would like first to talk about our reasons for this project, the requirement, the major requirement, our goals as engineering, step-by-step procedure, video explanation, and finally our anticipation in this project.
Now we are going to introduce our basic concepts in this project. In our solar charging station project, we divided it into two phases, the solar tracker part and the battery charger one. In the solar tracker part, the main component was mainly the solar panel, and this part will be used later on as a voltage source to our double rechargeable battery. Why we combine these two phases together, Michael will tell us why.
For our idea to actually come to life, we decided to go and see an actual charger which was found in Beirut at the Mercedes dealership. So we went to Beirut, we saw the actual charging station which was mounted to a wall. We saw that on top of it there's no solar panel. We decided if we're going to put a solar panel, it will be actually better. Instead of the sun rays and energy going for waste, we can use them for the solar charger. Second thing is, we went and looked more into the charger. The charger had many safety equipment in case of overheating and overcharging, such as temperature sensors and etc. So we decided, me and our team, to do a solar charging station from the idea of electrical car charging.
As shown in this slide, this is the material needed to implement the solar charging station. Due to the high dollar rate and the component scarcity, it's one of the struggle that we faced as engineers.
As I stated in the introduction, our project is split into two phases, the solar panel part and the battery charger part. This will be illustrated more in the following block diagram. The source of energy will be the sun for both phases, which will indicate the intensity of light for the 4 LDRs or the 4 photoresistors. These photoresistors will send an analog signal to the Arduino, which will be responsible for the controlling of the servo motors, which will be responsible also for the rotation of the solar panel. For the battery charger part, the solar panel will be our source of voltage, which will charge the double A rechargeable battery through a MOSFET and a 10 ohm power resistor. This will be done by using an Arduino and a smoothing capacitor, which will smooth the pulse of the pulse modulation signal, and the value of the voltage will be indicated through the serial monitor.
Dr. Gabi Abu Haidar telling us about Tinkercad before implementation has helping us a lot. This is the main schematic for our project that controls the solar panel directions. First of all, we connected a 4 LDR to the annual pins to indicate the intensity of light. When sunlight strikes the LDR, the value of resistor decreases. Depending on each LDR, the solar tracking system will follow the direction using the servo motors dual axis. This is the charging schematic that we'll talk about in upcoming video.
Here we have two flowcharts for each part, in which we had to include several libraries, we had to initialize and output different values, and we used different conditions in order for the project to work.
First, we soldered 4 LDRs to wires which we mounted on the solar panel. Second, we mounted the vertical servo motor to the solar panel and the horizontal servo motor to the plexiglass. Third, we made wooden brackets for X and Y axis rotation. Fourth, we connected the LDRs from A0 to A3 pins respectively. Then we connected the horizontal servo motor to pin 9 and the vertical one to pin 10. The solar panel gives out 5 volts for the charging stage of the breadboard. The 5 volt source charges the battery through a 10 ohm power resistor and a power MOSFET. The MOSFET is controlled by a PWM output pin on the Arduino. The pulses of the pulse width modulation signal are smoothed out by a capacitor of 1 microfarad value. The temperature sensor prevents the battery from overcharging and causing a safety hazard. Here's the charging part where it's giving different voltage values on the serial monitor.
Of course, in every project we had to face different problems. One of our problems was the conversion between Lebanese and dollar rate. Our second problem was the scarcity of products since people aren't bringing products anymore into Lebanon. Third of all was the malfunctioning of products. For example, an LDR wasn't working, so the project did not work. We had to troubleshoot it. To looking forward and always anticipating the best, our group and I were thinking about our future plans for this such project. First of all, we might add wind energy to the solar energy to make it more efficient. Second of all, to make an actual car charger. Third of all is maybe we could brand our project for later reasons and purposes.
And I are predicting that the dual-axis charging station will bring to the automation world the 20% more efficiency, 33% faster charging, and 40% more EV.
In a nutshell, our solar charging station project indicates how much Arduino is important in creating different kinds of projects, and by our project we'll be able to solve the crisis faced worldwide by using electrical vehicles instead of spending too many hours to fill up with gasoline. Thank you.